G'day everyone, how are you going? Video today on one of the forms of a quadratic equation. Remember there's three forms of a quadratic equation, or three common ones that we have. One of them is going to be this form here, so commonly called the turning point form. Now we'll explain why it's commonly called the turning point form, but that's a neat one to go. It's a good one to use because you can get a lot of information out real quick. Let's talk about this generic equation before we get on to examples. We've got three different variables in here. We've got our x and our y, and there we know about them. They're obviously on our axes. But the a, the b, and the c, they're the things that give the quadratic their shape. Now it doesn't matter if we write a, b, or c, or we write r, s, and t, or anything like that. It really doesn't matter. We've got to recognise that the number that's sitting out front of the square bracket does a certain thing. The number inside the bracket does a certain thing. The number at the end does a certain thing. So we recognise the place within the equation rather than the letter itself. So let's talk about these three. The first one here, A, that's going to control the shape of the graph. Okay, that's going to control the shape. Now I'll write a couple of notes here. This is going to get a little bit small, so follow along. The shape of the graph. If A is greater than 1, okay, if A is greater than 1, then what that means is it's going to be a steeper graph. Okay, let's talk about A equals 1 for a moment. A equals 1 is our standard shape. So when A is greater than 1, we're talking about a steeper shape than that. Okay, so when A is greater than 1, we're talking about a steeper shape. When A is between 0 and 1, between 0 and 1, what we're talking about there, because remember our standard shapes here, greater than 1 goes this way, less than 1 but still greater than 0 goes this way, it flattens out. Okay? If it's a very small number, 0.02 or something like that, then it would be quite flat. If it was something like 0.9, it'd just be a little bit flatter than our standard one. Okay? So in this range here, we're still in the positive way, but we're a wider shape. Okay? I'll leave A equaling 0 for a moment. I'll come back to that one. Let's flip into the negatives. So let's say that minus 1 is less than A is less than 0. Okay, so we're saying that A is greater than minus 1 and A is less than 0. So in that case, we're into the negatives, and instead of being up this way here, we're actually going to be the other way. Okay? But in a similar way, whereas this section here was shallower than the standard, this section here is going to be upside down, but shallower than the standard. Okay? So it's going to be something like this. Okay? As you graph more and more of these on your calculator, you'll see what I'm meaning here. Then we've got the next section, whereas when A is less than negative 1. So that's kind of the reverse of this one up here. Just that it's the other way. It's going to be steeper, but upside down. Right? Now I said to you, let's miss out A equals 1. Notice how I didn't have an equals here either one. If A equals 1, you've got to remember, if A equals 0, if this here is 0, 0 lots of whatever this is still 0. So if A is equal to 0, this whole part here disappears, and we actually end up with a straight line. So A will never be equal to 0. If it is, you don't have a quadratic. Okay? A equals 1. Let's talk about A equals 1 for a moment. I want to give you a little bit of an idea here. On our standard graph, if we go out 1 unit, we go up 1 unit. So we're here. If we go out another 1 unit, so we're going out 2 units, think of 2 squared. 2 squared is 4. So we're at 4 here. So from there we're now up there. Now notice how I went out 1 and I went up 1. I went out another 1, and what did I do? I actually went up 3. If I follow that along, I'm going to run out of room here. If I go up another 1, so I'm out 3 units, 3 squared is 9, 9 units, well I'm already at 4, that's another 5 up. So the common thing is for the standard shape, it's out 1 up 1, out 1 up 3, out 1 up 5, out 1 up 7. We're just going odd numbers each time. And if you write down your square numbers, 1, 4, 9, 16, 25, etc., the difference between square numbers is consecutive odd numbers. And that's why that works. You might want to sketch that out and see on a larger scale. That's our A value, shape. Everything about shape for A value. Our B value, this one in here, it's going to move the graph left and right. Now here's a little thing. When we're doing that, we're really saying, how do I make this part equal to 0? Now you might say, well, what's going on there? What matters? If I make this equal to 0, I actually want the opposite sign and number of this. Let me use an example. -3 here. To make that part equal to 0, I actually want to put 3 in there. So see how it's the opposite of that number there? So you might think this one is actually going to move it 3 units to the left. It actually does the opposite. It moves it 3 units to the right. I'll show you a bit more about that why. So here is my left and right movement. But remembering it kind of is a little bit odd. It goes the other way. We'll explain more. This number at the end, this because it's just added right at the end, it has nothing to do with the x values. This is just going to move the graph up and down. Just up and down. So that's the basics of what our numbers are doing. Let's do a couple of examples to try and get this settled. Remember our standard graph, I'll try and sketch it in here. Our standard graph is going to look something like that. Alright, at 0, 0, out 1, up 1, out 1, up 3, out 1, up 5. This graph here, I'll just dash in the standard one. The standard one would be something like that. Okay. This graph is moving 3 units to the right and 2 units up. So just think about where the turning point is moving from. The turning point here is moving 3 units to the right and 2 units up. So the turning point is now in this spot just here. So if the turning point's moved there, then everything else has also followed with it, because from here I would now go out 1, up 1, out 1, up 3, out 1, up 5. So I would end up with, it's not the greatest, something like that. You probably can't see that. The purple's not so great. Let me draw it again.
You want orange stuff?
If you've got it, yeah. Hey, there we go. Thank you. Perfect. Orange it is. Next one. So this is where this has moved to. It's moved 3 to the right and 2 up. So it's the same shape as the original graph. It's still a 1 shape here, but the position of it's moved. This one here, let's do the parts we already know. This here is going to move it 2 to the left. This here is going to move it 3 down. But this here, the shape being greater than 1, is going to make it steeper. So let me just get the turning point sorted here. Let's go. So -2, I'll put that about there. -3, I'll put that about there. So we're here. The turning point's moved from there down to there. Now here's where I've got to think about this 2. Remember it was out 1, up 1, out 1, up 3, out 1, up 5. Now it's out 1, up 2, double it. Out 1, up 6, it's double. Out 1, up 10. So as close as I can to a scale here, if I go 1 across, I've got to go 2 up, so that'll bring me to about there. 1 across, and I've got to go 6 up, maybe that will bring me to about there. And same on this side, it'll be about there and about there. So the graph would, as close as I can draw here, look, well, it's not the greatest here, a bit wobbly here, but you get the idea that it's a much steeper shape than my standard one. Now I haven't actually got much of a scale on here, but you get the idea. This is going to steepen it up. Last example over here. 1 left, 3 down, -1 is going to flip it upside down. So 1 to the left, there, 3 down, there. That's where my turning point is, and at this point it would be something like that. But the negative here flips it upside down, so flipping it upside down would give me this graph. Talking about naming of things, we call this concave down or a minimum. We call this concave up or a maximum. Either notation is fine, you'll find both of them. So this is pretty good. If we get it in this format, we can see where we're going. What if we don't? Here's an example, not in that format. Now I look at this and I say, well, I can't really even factorise that, because the factors here minus 1 and plus 3, or plus 3 and minus 1. I'm never going to get a 4 out of that. So I'm just going to struggle to do that. So we complete the square on this one. Let's do that. So, got it here. Take this 3, move him right over to the side here. Get him out the way for the moment. X squared plus 4x. Now the rule is, you halve this number and square it. And in this case, that's going to be 4 anyway. It's not always. But halve that, 2, square it, 4. Add 4 on, and take 4 off. I didn't change anything. And then don't forget your minus 3 at the end here. Now I'm just going to look at that section there. I'm just going to factorise that. And I should see that I can get x plus 2, x plus 2. Multiply that out in your head. X squared plus 2x, another 2x, bingo, 4. Got it. And I've got this minus 7 on the end. Isn't this the same thing? So won't this just become x plus 2 squared minus 7? And isn't that now in this format? So we can go ahead and do our normal graphing of it. What is it going to look like this one? Minus 2, so we're going to be over here at minus 2. Minus 7, we're going to be way down here at minus 7. So we're going to be about here. Standard shape, no number out the front. So therefore, I reckon we're going to be out 1 up 1, out 1 up 3, out 1 up 5, out 1 up 7. You get the idea? It's going to be something like that. Something like that. Now my tips here are, as you're working through this and understanding and getting the hang of this, do a question, jump on your class pad, type it in, graph it, look at it, go, yep, that's the one, I got it right. The key things are these. There is one more thing that sometimes creeps in here, a 2x or a 3x in here, but I've left that out for now. Keep it simple. When you do those ones, maybe I'll do another video for that, but these are the ones that come up all the time. You can also have something in there. Leave it for the moment. Hopefully this one helped. Catch you later.